In this lecture, we are going to re-implement the trend following strategy. This time, we're going to use a reinforcement learning API where we have explicit environment and agent objects, which interact with each other. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. So a lot of this stuff is going to start out the same as before, but just in case you spent a long time learning about reinforcement learning, I'll go through everything again as a review. So we'll start by downloading the SPY CSV. Since this is trend following, we only need the daily close prices. Next, we're going to import pandas, numpy, and matplotlib. Next, we're going to read in our CSV using pd.readcsv. Next, we're going to calculate fast SMA and slow SMA. We'll also create a variable called feats, which will contain the column names of these moving averages. Next, we calculate the log return by taking the log of the close prices and then the difference. Next, we split our data into train and test with the last 1,000 points for the test set. Next, we implement the env class. The first function we have is the constructor. The constructor takes in one argument, which is a data frame. This will either be the train or test data frames we just created. Inside this function, we set df to an instance variable. We set n, the length of df, which we can use to determine when we reach the end of the data frame. Next, we set current index to 0. This will keep track of our current position in the data frame. Next, we define the action space, which will be the integers 0, 1, and 2, corresponding to buy, sell, and hold. Next, we set our invested flag to 0. This will either be 1 or 0, corresponding to true and false. Next, we set the states instance variable. This will be the data frame columns specified by the feats list we defined earlier. We'll also convert this to a numpy array for more convenient indexing. Next, we set the rewards instance variable. This will be the log return column from the data frame, also converted to a numpy array. Finally, we'll also keep track of the buy and hold return. This will be accumulated in an instance variable called total buy and hold. By the end of the episode, it should be equal to the sum of all the log returns that could have been rewarded by the environment. Next, we have the reset function. Inside this function, we reset the current index to 0. Then we set the buy and hold total to 0. We also reset the invested flag to 0. Finally, we return the initial state, which can be obtained by indexing self.states at location 0. Next, we have the step function. This takes in one argument, which is the action that the agent performs. Recall that the step function should return 3 things: the next state, the reward, and the done flag. So all the work we are about to do is to compute these 3 things. We start by incrementing the current index. Conceptually, this is bringing us to the next day. As a sanity check, we can check whether or not current index is greater than or equal to n. Since it should never reach this point, we raise an exception if it does. Next, we check the action. If the action is buy, we set invested to 1 or true. If the action is sell, we set invested to 0 or false. Next, we compute the reward. If we are invested, then we return the reward at the current index. Otherwise, the reward is 0 because we are not holding any stock. Next, we obtain the next state. This is simply self.states indexed by current index. Next, we add the current log return to the total buy and hold counter. Finally, we set the done flag. This should be true whenever current index is equal to n-1. Lastly, we return the 3 things we promised we would: the next state, the reward, and the done flag. Next, we define the agent class. First, we have the constructor, which does not take in any arguments. Inside the constructor, we set one instance variable, isInvested, to false. Next, we have the function act. This takes in one argument, which is the state. Inside the function, we do a sanity check to ensure that the state has length 2. The state should be a vector containing the fast and slow SMAs. Next, we determine what the action should be. So if fast is greater than slow, and we are currently not invested, then isInvested becomes true, and we return 0, which means buy. If fast is less than slow, and we are currently invested, then we set isInvested to false, and we return 1, which means sell. If neither of these cases are met, we return 2, which means do nothing. Next, we have the playEpisode function. This function takes in two arguments, which are the agent object and the env object. Inside the function, we start by calling env.reset. Next, we initialize done to false. Next, we initialize total reward to 0. This function will accumulate the total reward for the episode and then return it at the end. We also make sure to set agent.isInvested to false, so we begin each episode uninvested. Next, we enter a loop that finishes when done becomes true. Inside the loop, we begin by calling agent.act to obtain the action for the state. Next, we call env.step, passing in the action. We obtain the next state, reward, and done flag. Next, we accumulate the reward in total reward. Next, we update the state variable to the next state so that on the next iteration of the loop, it represents the current state. When we are finished, we return the total reward. Next, all we have to do is make use of all the hard work we have just done. We start by creating two environments, one for train and one for test. Next, we instantiate our agent. Next, we call play1episode using our agent on a train env. Next, we call play1episode again, this time using test env. Next, we print out the train reward and also the buy and hold total for the train set. We get about 0.43 and 0.597, which correspond to what we got before. Next, we print out the test reward and the buy and hold total for the test set. We get about 0.08889 and 0.193, again, corresponding to what we got before. Okay, so I hope that this lecture helped to solidify a few concepts. Firstly, I hope it made our code from earlier make more sense. When we first encountered trend following, it was more like manipulating a data frame. In this lecture, we actually got to implement an agent and an environment, and we could see them interact in a more realistic way. Secondly, you learned about some very crucial components for reinforcement learning, including the environment, agent, states, actions, and rewards. Knowing what you know now, the Q-Learning script will seem like a small adjustment to what we've done so far.